I'm a customer success architect with Talend. So mostly my group, we focus on best practices, architecture, design, how best to use Talend products. Today we're going to go through some best practices. I think the last meetup you had here, Venkat, which is one of my colleagues, presented best practices 1 through 16, right? And so today we're going to start off at 17 and kind of move forward, and we'll see how far we can get. So these best practices are based on a blog series by Dale Anderson. So you can find those if you go to talend.com/blogs. You can look for Dale Anderson there. He is the regional manager in the US for the customer success architecture team. So there you'll find 4 parts. Parts 1 and 2 were what were done last time, and this time we'll start off with part 3. It's an open discussion. Just feel free to let me know if you have any questions as we go, and we'll just get started. Okay, so whether you're a new developer or you are a seasoned developer, and really no matter what tool that you're using, you always have the same kind of question, right? What's the best way to use this tool? Or in Talend's case, what's the best way to write a job, right? And really you want it to be easy to read, easy to write, and easy to maintain. These are the 3 basic things that you're trying to do with a job. But it's really difficult to do all 3. So you need to choose. All right, so if the job's going to change a lot over time, then you want to make sure it's easy to maintain and easy to read, right? If it's not likely to change, then you only care about writing it. So it'll be easy to write and easy to read. If you have a lot of developers, which many of you probably are in that situation where you're working with other people, you want to make sure it's easy to read and easy to maintain. It's kind of straightforward, obvious, but it's good to think about when you're making your jobs, right? So Talend is a code generator, right? But with Studio, you have a canvas, and you are painting your code. You have a palette of different components that you can choose from. You have a repository that you can choose from, and you drag them into your canvas. So it's kind of easy to use in that way. But at the same time, as I said, it is a code generator. You do have to worry about the basics, right? You have to make sure that you have good error handling, for example. You have to think about how much memory your job may use. If you're doing certain types of lookup joins, for example, and you're bringing all the lookup data into memory, you have to think about these things. Your job server only has so many resources, and these are still things that are kind of on your radar when you're building jobs. So we do have a software development lifecycle best practices guide. This is something that you can find on our help.talend.com site. Definitely look that over. It's really easy to find. You type SDLC, best practices, and it'll pop up as one of the first search items on the help. Definitely look at that. It's about a 30 or 40-minute read. It'll walk you through a lot of what we recommend for best practices. You'll find a lot of information out there for like CI/CD if you're looking to do that. Continuous integration. We also have some knowledge base articles on how to set up Jenkins. So if you're looking to do a continuous integration setup, you'll find all the information out there. All right, so we'll get started with the best practices. First, we're going to recap 1, okay? This is from the last one, just to kind of get warmed up. So when you're laying out your jobs, it's really recommended that you don't just splash your components up there. Don't snake them, right? Don't make it look like some work of art. Really, it's very difficult to maintain when you do something like that. You have scroll bars. You can easily use them. Really, the recommended approach is top to bottom, or left to right, and then top to bottom, right? You can always scroll over if you need to. You can always scroll down if you need to. The reason why we recommend this is a very simple best practice, but the reason why we recommend this is if you have to insert a few components in and you've done a snake, for example, then you'll have to move all these components around and cascade that movement all the way down your job. It's very difficult to maintain, right? So this is why we generally recommend going left to right, top to bottom. Animations. Okay. Then we'll also recap another best practice, because some of the information from here will come in a later best practice that we'll talk about. And this is understanding the difference between a joblet and a T-run job component. So a T-run job is how you orchestrate to have a parent job make a call out to a child job. Okay. Very common scenario. You'll set up. You'll have some jobs. As long as you're not creating huge monolithic jobs, which you should not be, right? You should compartmentalize everything, make things parameter driven, what have you. You should have a parent-child relationship between these jobs. T-run job is that component that you'll use to call that child job. A joblet, on the other hand, is a little bit different. This allows you to include code into your current job. And the real difference here is the context in which that included code is running. It has full access to the context of the current job that you're running in. One very common scenario, let me see if I can make this blow up a little bit. That's a little better. One common scenario is to have a log processing joblet. And this is one that uses a T log catcher, and it will listen to any errors that may have occurred during that job, and it will process them accordingly. You can direct certain types of errors or warnings or fatal or whatever kind of situation you have certain ways. Send an email, put it out to a log, write it out to the screen, things like that. Okay? And you can consolidate all of that into a single joblet that you include in all of your jobs. Now, if you were to try to make a child job out of that using a T-run job, you would find that that would not work, because it would not have the context of the current job to listen for errors, right? It will be in its own window, basically. So that's really the differences between those two. You may find other reasons to use a joblet. Most of the time, you're going to use a T-run job. Okay. All right, so now we'll start on some of the new best practices. Oh, if anybody has any questions, yeah, go ahead.
I have a question about the difference between joblet and T-run job. Is there a difference in terms of performance between using?
Okay. So he's asking if there's a difference in performance between using a T-run job and a joblet. It's really just different. It depends on how you're using it, right? A joblet is included code, but you need to be a little bit aware that every time you use a joblet inside of your job, it's actually duplicating that set of code over and over and over again. That can cause you an issue if you use something that is extremely complicated and you put that into a joblet, for example, and then you place that joblet 20 times inside of one job, okay? That can cause you some problems. Right? It actually could cause it to not compile because you may hit some certain Java limitations as far as how long a single method can be. Right? So it really just depends on what you're doing. We'll go into a little bit more some other good uses of joblets a little bit later. Any other questions? Okay. All right, so best practice number 17 is know about code routines and when to use them, right? Code routines, there's different ways of adding custom Java code to your project or to your job, right? So one way is to use our code components. We have a tjava component, we have tjava row, and tjava flex. Each have a different purpose. Some are just, tjava, for example, is just for executing whatever Java code you want. Tjava row is for executing Java code for every row in a data flow. So you can do some transformation, you can do some summarization, or whatever it is that you want to do on a per row basis, right? And tjava flex is a little more of a kind of a complex, all-encompassing Java code component that has a initialization phase, a row by row phase, and then a finalization phase, so that you can, you can do something a little more complicated if you need to. But there's other ways to also add Java code into your project. Instead of using the code components, which are tied to only specific jobs that you have, you can use what's called code routines. These code routines, let's see, let me make this a little bit bigger. You can see. Okay, so with these routines, you're able to basically set up a custom function that takes in some inputs and returns some outputs. These routines can be also based on a library of any kind. So if you have like a jar file that you want to load and you want to use a class inside of a jar file and do something, an example might be like the Google JSON library for making pretty JSON or something like that, right? That's just some random one I thought of. You could include that as part of your routine, and then you can make calls to the methods inside of that jar file, right? And by creating the routine, you have now made this function available anywhere in your job, whether it be as a setting someplace or part of a tmap or used inside of another tjava component. Any of that's possible. It's a good way of creating reusable code as well, because this is a project level, not a job level. So all the tjava that you create are going to be components within your job, but a code routine is something at the project level. The other thing to mention about this is with routines, you can also set up a little bit of metadata using kind of like a Java doc format almost, where you you can define what each parameter is, what the return is, what the purpose is of the function. And when you're in something like a tmap expression editor, you can see all of that information just like it was any other function that you could call. Okay? Any questions on that? Go ahead.
Is that still the best practice if you're operating on a data stream?
If you're on a data stream?
Yes.
So it's really the best practice for, sorry, go back. It's really the best practice for reusing your code. So if you don't have a reason to reuse your code, like let's say you're just doing a one-off something inside your job that you're not really going to use anywhere else, you can use tjava row, right?
If you're performing analytics on a data stream, how would you still be reusing the same code?
Well, if you want to reuse the same code, like let's say you have certain formulas that you want to use throughout many jobs to do certain types of calculations, yeah, you would use code routines for something like that. Yeah.
Is there anything that you can augment?
I'm sorry?
Is there anything augmented that you can have for specialized case of streams, or it's the same marker?
It's really the same. I mean, so you're talking about we're talking about data integration jobs really here. I don't know if you're talking about big data streams or you're talking about big data streams.
Yes.
Okay, it's a little bit different with big data streams. I'd have to do a little bit of research on that one because I actually don't know if big data streams has access to the code routines or not. So that's the question. Yeah, I can look that up after. Yeah.
Thank you.
Sure, no problem. Yeah, a lot of what we're talking about today mostly applies to our data integration part of our product. So standard jobs, basically. Some of it will apply to big data, but not all of it. So. Okay. All right, repository schemas. So we do have a repository schema. That's what you see on the metadata side on the left side of your studio. You can set up all sorts of very useful things in there, connections. You can do schemas. We have schemas on a per database level or file type level that you can create. You can also create what's called generic schemas. Generic schemas are very useful because you can pretty much import them into any component, right? Whereas a database specific component will only show up for those database components. So that's definitely recommended. Put your schemas in there, especially if you plan on reusing them more than one time, right? They're very, very useful. And these are all stored at a project level, right? So all jobs within that project. Or if you create reference projects, then anything that references that project would also inherit all of that information. So. Okay, so all of our components are enabled for Log4j. You know, they all emit log information that is useful and can be captured using Log4j. You're able to set up, let me also zoom on this one. You're able to set up in your studio, not sure, it's probably still a little bit small, but, and I don't think I can use I can use that. So you're able to set up in the studio some configuration for outputting to the console and also for outputting to the log stash. So if you have the Talend logging services installed, that's basically an ELK, that's the Elasticsearch, Logstash, and Kibana. You're able to use Logstash here to pull all the logs for your jobs when they're running and to put them into Elasticsearch for display in the Kibana dashboard. And on the tech side, when you're executing these jobs, in the job conductor, you can set up the images coming. You can set up the job to execute. There we go. Maybe. There we go. You can set up the job to log at whatever level you set it to. Info, debug, fatal, whatever. And that's something you can set right at the TAC level. So if you're having an issue with a job, for example, you can go out, in TAC, the administrator can actually go out in TAC. You don't have to get a developer involved. You just have the administrator go out there, and you can change what debug level you're seeing, and then you'll get all that good information. So if you're using this, it's recommended to use our tDie, our twarn, or tassert components. These will output information to the log. And we also have some other best practices that were shown last time around having some type of naming convention, some error code conventions to make things a little more meaningful going into the logs. Okay, next we have the activity monitoring console. And this is basically, this is something that you can use with your jobs to get more detailed information about how this job is running. You can see what's flowing between, what is the number of rows that are flowing between components. You can see the status of various components within your job, how long it's taking for each component to execute, how much time is being spent in each component. You can see a lot more detailed information using the AMC. The AMC has two views, and one of them is in your studio. There's actually a perspective just for the AMC, and you'll be able to see, and I'll show you in the next slide, but you'll be able to see pie charts that tell you how long is spent in each component, things like that. Right? It also exists on the TAC server. Now this image here is actually not the TAC server, even though this slide says TAC. This is the studio, and this is the AMC console that you would see inside the studio. All right, so best practice number 21. Oh, go ahead. Mm-hmm.
Is it possible to integrate AMC with Kibana, for example, for active monitoring from our DevOps teams?
AMC with Kibana. No, AMC, so AMC only outputs to 3 different tables that you set up in some other database, really. I mean, it can be any database. Kibana will pull off of Elasticsearch. Now, what you can do is create some additional log stash and create new indexes in your Elasticsearch, and then create some dashboards on top of that. So I have seen people do that.
Because that is something that we're pursuing. It's like active monitoring of the jobs, and it's know exactly when it's slowing down or when it's like starting to die, so that we can actually proactively
Okay.
without having to like do it afterwards and go into the logs and dig into the logs afterwards.
Right, I understand. Yeah, I would look at, I'm not really sure if it goes into Elasticsearch as it's going, or if it gets sent after the fact. I'm not really sure about that. Yeah. I mean, you can definitely see in the AMC, you'll be able to see some of that, but it will be only those 3 tables that you create as part of the AMC. Yeah.
Okay.
So, okay. Go ahead.
I don't understand how is the job expected to behave once we rerun it.
How the jobs.
Let's say we had an issue, but configure the checkpoint.
Okay, yeah, we'll talk about the checkpoints right now. Yeah, I'll try to explain it to you. So that's coming up now. So, all right. So next we have the recovery checkpoints, and so this allows you. Let's say you have a job that has a few steps, and one of the steps you have is kind of a longer running step. If the job fails after that step, you would not want to have to restart, right? You want to be able to continue where you left off. That's where the recovery checkpoints come in. So with the recovery checkpoints, what you do is, make this a little bigger, okay? So what you do is, this is actually a setting that is on the subjob OK trigger, so in between subjobs, okay? What you do is you enable the recovery checkpoint. This is under the error recovery section, and you give it a label, and then this becomes a checkpoint that you can use. So if there is a failure, the administrator can go in through the recovery manager and continue that job where it left off from wherever the recovery checkpoint is. So you have to also think about where you're using this. You can't just, every subjob OK is going to have a recovery checkpoint. It doesn't make sense, right? You're going to have certain subjobs that do certain things. You're going to have certain commit points, right, with your data. You make sure that, before you move on to the next checkpoint, that is something that can be continued from that point, right? So there is a little bit of, it's not automatic. You do have to think about it, but as long as you structure your jobs a certain way and make sure that all the data is committed by a certain point, then you can use these recovery checkpoints. Now, you can also put in some failure instruction here, and this is something that shows up on the administrator side. So when there is a failure, they'll be able to see, well, in order to use this checkpoint, I may have to go out and clean a few files, delete a few files here, maybe change something here, something that isn't covered by the job, right? There sometimes is some cleanup that has to occur. Those are messages that you can kind of pass over to the administrator here. And you can tell them, as the developer, you probably know what's getting left out, right? What isn't in the right state if you try to do the restart. So this is where you would put that information there for them. Okay.
Kind of instruction for manual intervention?
Yeah, you could do, yeah, exactly. It's for manual intervention. If you need it. You may not even need it, right? Okay. And this is just what it looks like on the tax side. So you have the ability to either just, as I said, continue the job where it left off, restart the job from the beginning, try to recover it automatically. There's some automatic recovery where it'll just figure out, what it needs to run, what checkpoint it needs to run from, things like that. So that's what it looks like from the tax side.
Clarification. Are the checkpoints manually determined, or is there some sort of algorithm based on cash that's proportional to cash usage?
Okay, so he's asking if the checkpoints are automatically figured out, or if you're figuring them out yourself. Is that right? Is that the right way? Okay. So you are figuring them as a developer of the job. You are determining where those checkpoints are, and you are naming those checkpoints specifically. So you have to know, that all your data is committed before a checkpoint, for example, and don't hold the commit to a later point, because then that really isn't the right place to put a checkpoint, right? Yeah. So that's up to you as a developer to figure that out. Yep. Okay. All right, so best practice number 22, this is joblets. So if you remember, I mentioned earlier that you could create a log catcher, and you can kind of determine what you want to do with the errors that occurred, right? So this is basically a place that you would do that. We do recommend doing that. It's good to handle all your logs, all your logging information a certain way or a standard way for all your jobs. And to do that, you would just create a joblet. This joblet, let me blow this up a little bit. This isn't the right one. All right, what happened there? Interesting. Okay, so I can't blow that one up, but so this is one example, though, of a joblet, of a place that you would use a joblet. So here we have a catch log. This is a catch log, a log catcher, T-log catcher component. And you can think of it almost like a listener. It waits and listens. And if the job emits any logs, this thing is going to process it. Okay? And then you determine what type of log it is. If it's a debug log, in this case, for example, we're putting out to a file someplace. Info, we're putting out to a file. If it's an error or a fatal, then we're sending an email, right? So this is just an example of what that joblet looks like that we talked about earlier. Other uses of joblets would be if you had some type of maybe standard transformation that you wanted to do. Joblets can take an input and an output. So you can have an input schema, you can have an output schema, you can have components in between that manipulate these. You could, or you don't even need to have an output, for example, or an input. You don't have to have either one of those. So it's pretty flexible in that way. And so if for example, this example here doesn't have an output because you see it's grayed out. It does take in an input, and it basically writes out to a MySQL table someplace. But you could, for example, have an input and an output in some type of TMAP or filtering or something like that in here if you wanted to. So this is another use of a joblet. Okay. Another thing I'll mention is just remember joblets are saved at a project level, right? So you can reuse them in many jobs, and that's part of the alert to using a joblet. Okay, so test cases. So if you're doing, especially if you're doing CI/CD, but even if you aren't, you may want to be using test cases. So test cases is something that you can do in Talend where you are going to isolate certain components in your job, and you're going to test the functionality of these things. You're going to create an input file and an output and an expected output file. And you can create many of these, right? You can create input files that represent all different types of data that you might receive. If it's small data, large data, big data, tall data, short data, red data, blue data, whatever, right? All different types of data. And you can create all these different test scenarios, and you can run them through various components of your job and make sure that they are actually running the way you want. It's kind of a unit test for your jobs. If you're doing CI/CD, then this is something that you would have automatically running whenever it builds your job. So, a CI/CD Jenkins, for example, is going to see that you have checked in some new jobs, right? It's going to bring them down, compile them, and then run the test suite that you have created as part of your job. This is actually something that you create inside the job itself. I think I have a picture of it here. Right, so as I mentioned, it has an input file, an output file. You either get a pass/fail. So if it generates the output that matches the output file, then it's a pass, right? So this is actually under a tab. So if you know where the component, the run tabs are, there's a tab called test cases, and this is where you can create all of your test cases for any given job. Did anybody here use test cases, by the way? No? Okay. It's a good feature. You can try it out. Yeah. All right. This is number 24. All right, so this is about iterations and basically understanding our iterative flow and our flow to iterate. So I don't know if you're familiar with iterative flow. Certain components, for example, will produce a data flow, and that's usually what you're used to seeing, right? Some components are like an input component, for example, is just going to query some data and then produce a data flow that you're working with. That's the main data flow, right? In some cases, you may not be working with a data flow. You may need to iterate. So we do have some components that allow you to convert from a data flow to an iteration. Now, an iteration is when you want to execute something. Like let's say you want to make a REST API call for every row that comes out of the database. Okay? This will be a case where you may want to convert your data flow into an iteration, which is basically like a loop. We have a T-loop component, for example. And you would execute that REST API call for every row that is inside your data flow. Okay. All right, so next we have T-map lookups and kind of understanding some of the settings behind the T-map lookup. So lookups, you can do lookups 3 different ways. T-map can do a join. It can also do formulas and what have you, but it can do joins, right? And with these joins, you can set up what kind of lookup you're going to do. Are you going to read the entire lookup table into memory and then just pull from that as you get matches? Or are you going to do more like a lazy load, right? Where as you encounter new IDs, you may query them from the database and then hold them in memory. Or you may not want to hold them in memory at all, right? It just depends on what kind of situation you're encountering. And if you have a lot of data, for example, in your lookup, 1 million rows in your lookup table, 2 million rows, you probably won't want to pull that on the RAM. In that case, you would probably want to do a row by row. Now, if everything you're doing is probably going to be a unique lookup, then you probably have no reason to cache that information. Because if you're doing 1 million row processing, and it's generally going to be a unique lookup each time, then you wouldn't want to cache that, because then you'd have 1 million rows in memory at the end anyway, right? So there's different settings there that you need to be aware of. I think the next one. Yeah, so this is the lookup model here. So you have the load once, or you have the load and cache, the row by cache, and the row, and then just the regular row by row. Yeah, so load once, reloaded each row, reloaded each cache. That's those are the parameters that you might set there for the particular join that you have. So again, it just depends on what you're doing. One moment here while I show you how to do it. Okay, so if you're doing a row by row, then you will need to define how that query is going to pull each row. So what you end up doing here is on the lookup component that you are bringing into your T-map, you're going to specify the query, and you're going to use the variables that are being looked up from the T-map. These are things that get put into the global map. So it's very, very similar to how iterations work. Putting data coming out of iterations, it'll put them onto the global map. It's a very similar idea. So here you actually build the where clause for how that query occurs, right, to pull that single row. It is expected that this will return only 1 row, though, so just be aware of that. Any questions so far? All right, number 26 is just about understanding the different type of global variables that we have in Talend. So we do have context variables, which you're probably aware of. And these are, you think of these as kind of like parameters going into your job. It could be connection parameters, could be username, password, it could be table names even, or schema names, or what have you. They're, generally you think of them as parameters. But we do have other global variables as well. So one is just the global map variables that you see. And you can put things inside the global map by using one of our components. It's called tset global var. And these are very often used for situations where, let's say you want to pull the max value out of a table and then use that max value in a future query. Well, you'll need a place to store that temporarily, right? And that's a good use of the tglobal var. You may have a query that says, give me the max date that I've processed so far, put it into a variable, and now pull everything greater than that max date, right? And so the greater than that max date would have a where clause that said where the date is greater than whatever it is, the global variable that I just pulled, right? Or just populated. So in big data, we have a similar concept as well. It's a different component, though. It's called tglobal var load. It's the exact same concept. And as I mentioned, use the global map to access these things. It's just global map.get, and then you'll want to cast the data type properly. So if it's whatever data type it is, you'll want to make sure you cast it. And then we also have some system global variables, things that are internal with Talend. So if you haven't really looked at it, we have something called an outline. And an outline will show you a list of all the components that are used inside of your job. Underneath that tree, you will see all the global variables that exist that you can use inside your job that come from those components. So if you have certain components may have, what's the line count that I just processed, right? What's the error message that came out? Well, like for example, with a T-run job, you would have, what's the child's error message, and what's the child's error value, right? And these are all global variables that you can access, and you can literally just double-click these inside of, and they'll pop up into your window over here and pull it right out of the global. It'll put the statement for you for pulling it out of the global map, so you can access all this over here. This is also useful for things like ABC. If you're doing auto balance control, for example, you want to see a number of lines. Instead of putting a component in there, I've seen some customers do this. Instead of putting a component in that's counting the number of lines that are going through the data flow, you don't really have to do that. You can just ask, after the fact. You can say, how many rows did you process? And you can get that information. So. All right, so best practice number 27. Know that you can load your context. So you can load context from just about anywhere. You can have context in a file. You can have context in a database someplace, and you can load it from there. So you can maintain all of that context parameters for how your jobs are going to run, and you can put them in environment-specific places. Whether it be a file somewhere in your job server, or if it's a database someplace where you're keeping all that information. You're able to do all that, right? That's just using a T-context load. Go ahead.
I know there is some place in the interface where you can define the environment names, like QA, production.
Yeah, the context groups.
And
Yep.
set the context groups, and then set our variables there. Is this an alternative to that?
Yes, this is another way to do that. So, so what he was just bringing up is, in the interface, you're able to create context variables and context groups, right? You can have a dev, a QA, and what have you. This is a way of setting those from another source. So instead of saying, I'm just setting it to be whatever group I have, like I'm setting it to dev or QA or prod, and it'll use all the variables that you have set up there, you can actually override the underlying ones based on another source someplace. Very often, you may have a situation where you don't want developers to have access to production, and you don't want to give them production passwords, right? So in these cases, you may want to load that context from someplace else. So sometimes people put them in files and put them on the job server someplace. Sometimes they put them in a database. And, there's different ways that you can do this, right? So this is one use of that. You can create the initial load, the initial set of data for this by using a tcontext dump. So all the context variables that you set up in the interface, you can then dump them someplace, whether it be to a file or to a database or whatever, and then you can modify them. So it makes it a little bit easier, so you don't have to manually go through and type in each one and hope you get it right. Yeah.
Let's say we would like to upload our job to the Talend integration cloud.
Okay.
How do we specify which context group they're going to use?
Okay, yeah, Talend Integration Cloud is a little bit different, especially around the context groups, right? Because they're really not there. You have to do those. Context groups in Talend Integration Cloud are environment specific, so you have to set them up for each environment. Yeah.
Okay, so I mean, when you do run here, you can set run as dev or run as production.
Right.
When you upload to your cloud, which group will be uploaded?
Okay, so I'm not sure which one would be uploaded by default. Actually, I know that in Talend Integration Cloud,
You can set default for one.
yeah, I think you can only set it to one. It doesn't support the context groups being able to pick the different context groups. Yeah,
The
so
one that you set as default would be the one.
I think it's the one you set up as default, but I'm never personally tested it, so yeah, I don't know for sure. So okay. Okay, so using dynamic schemas. So Talend does have, for our standard jobs, dynamic schema, right? So if you have, let's say, a very standard load operation that you need to do, and you're just going to bring in that data however it exists, you're going to create the table with whatever columns are in the incoming data, and you want to just load them. And you just want to follow the same type of process. You have 100 of these, right? You don't want to write 100 jobs. You can use dynamic schema. And what you do is you keep some metadata around what these columns are, and you can load that metadata as part of the job. And then all the components can use that as a dynamic schema. So instead of hard coding the schema for each of these components, you're setting the schema at runtime. So you basically create, two jobs. One to create the dynamic schema that you're going to use, and the next two is your job to actually load that dynamic schema and run. So that's, you can pretty much do it in 2 jobs. Yeah.
What's the pros and cons of using dynamic schema compared to dynamic data type? Because dynamic data type also exists. So
Yeah.
you can give it like a dynamic data type in a generic component and just pick up the data type at one time.
Right, yeah. The dynamic schema versus using the dynamic object, is that what you're talking about?
Dynamic data type.
Dynamic data type. I'm not really sure. I don't actually know a lot about dynamic data type. I know about the dynamic object which works for certain components that don't support dynamic schema, because I know that not every component will support dynamic schema. And in those cases, I believe use the dynamic type, but instead, yeah. Okay, so dynamic schema components. You can query the information schema to get a list of all the columns for the tables you're trying to load and use that for your dynamic schema, right? In a lot of cases, we already have components that are going to query the information schema for you, so you don't have to figure out which one, what schema to look at. We have one for MySQL, for example, for Oracle. Basically, if you see table list or column list, with your database that you're looking for in here, then we can pull the schema automatically for you. You don't have to go hunt down the information schema and figure out, am I going to use all tables or whatever. All right, so best practice number 30. So know that we have change data capture capability built into Talend. We do have a series of CDC components, and they support all different types of databases. Basically, if you see, just like the previous one, if you see a component with your database name and CDC on the end, then it's supported, right, in some way. It's kind of a, this is when you need to do like a publish subscribe type model, trying to detect change and apply. Depending on which database you have will change what method you're using. Basically, if you're using Oracle 12, then it's going to use Xstream. If you're using Oracle 11, then it's going to use the archive logs, right? And otherwise, it's going to use a trigger-based method, where we're just, we create an insert, update, delete trigger, and we write it out to another table that we're going to, the CDC component can then read against. We do have a whole chapter in our documentation on this. So you can read that, chapter 11, lots of information. So if you're looking for CDC, look there. All right, best practice number 31. It's all about custom components. So I don't know if you know, but we have an Exchange, and lots of folks create components that we don't already have. Maybe they have something special that they're trying to do. For example, the one I see there all the time at the top is the Google Analytics, right? So if you're trying to pull data from Google Analytics, we don't have a component for that, but somebody has written one, and somebody has posted it for, for the community to use. So you can always check out there. In order to use custom components, you do need to set up your studio so that it knows about, it has a place to put these. It's basically in your project preferences, and you just set a directory up and say, this is where I'm going to put all my custom components. And anyway, you can go into the Exchange. There's the setting right here, sorry. Yeah, it's basically under components, and there's a user component folder that you set. And if you want to add from the Exchange, you can either go to the Exchange and download it yourself, or you can go through Studio. We have an Exchange tab that you can click on, and then you can find the component you're looking for, and click the install, and it'll put it in the components directory that you set up for you. And then you can use it. You can also build your own, right? So we do have some examples out there on how to build components. You can build components based on other components. So if you're trying to add functionality that we maybe don't have in a certain component, you can do that pretty easily. You do need to set up the custom component, just like I showed you earlier. And then there's two different ways of creating components. One way is really not public yet, I guess. We haven't produced all the documentation behind it. It's called TComp, or Talend Component Framework. And that's coming out, I think, in the fall. I think the documentation behind that is going to be released to the public. So that's something that's coming. It's more of a pure Java implementation for components. And then we have what we've been using for a long time now, which is Java Jet. It's basically a template-based code generation system for creating Java code that goes in your job. So you have a begin, a main, and end. It's very much like the tjava Flex if you use that. A lot of the same concepts as to where the code goes. It's, as I said, it's all template-based. So if you create, this is just some examples of what it looks like when you're working through the component designer, which actually has been, as I said, we're moving into the TComp. So the Java Jet framework is being deprecated. But very soon the TComp will be the new way to go. So we'll have some expert sessions on that probably in the fall, walking through how to set up the Talend component framework and how to build maybe your first component. So look for that in the fall. All right, this is the last best practice, and then we'll start summing up. So what's behind a job, right? What is a job? When you have your canvas open and you're adding components to the job and you're creating this job, what is that really, right? Under the hood, it's not generating Java as you go, right? It's actually using a job script. It's creating a job script under the hood, okay? This job script, it's creating XML files that have what basically is just like this job script that I'm showing you here. It's very similar, where you can basically say, I have certain components, I have certain data flows between these components, and you can define all of that information. So you can actually generate jobs if you ever needed to. We do have some customers that do this in certain cases. Data Vault is kind of an area where a lot of folks do generation of jobs. So that's something. So yeah, we do have some customers that do this. Not too many. Not too many. All right. So we'll start summing up here. The success-driven projects, right? So the key to being successful with really any project is understanding the use case, having the technology, and having a good methodology behind it all, right? And Pablo Picasso, action is the foundational key to all success. What does that mean, right? That's basically start now, right? Start working on your best practices now. You can implement a few best practices at a time. You don't have to do them all in a big bang. You can, everybody here can, go back and everyone agrees to label every one of your components or something, right? Something very small, something that everyone can do, and then you kind of incrementally build on that over time. But the sooner you start, the sooner you'll get to where you need to be. Okay, and that's pretty much it. So I'll just leave that up here if anybody has any questions. Okay.
Job scripts that you deploy, are they framework agnostic or?
The job scripts? The job scripts are really meant for Talend to generate Java code. Yeah. So, you can create the job scripts any way you like. So if you want to write a Python script to create job script that you then load into Talend, you can do that, sure. Yeah. Mm-hmm. Anything else? Okay. All right. Well, thank you. All right. Be around.